In this first problem, we have a piece of metal that weighs 50 newtons in air, 36 newtons in water, and 40 newtons in an unknown liquid. We want to find the density of the metal. So, to draw our picture, we would say, well, in air, if we were to hang this by a scale, it would read 50 newtons. In water, would read 36 newtons, and in some unknown liquid, it would be 41 newtons. Okay. So first we want to find the density of the metal. So remember, density is mass all over volume. Okay. So if we know the object's mass and its volume, we're going to know its density. So the first step we do is, well, we know the force of gravity in air, right? If we think of this as a free body diagram, we have gravity and our tension force. Our tension force reads 50 newtons. That must be our force of gravity. So let's write an expression for the force of gravity. We have force of gravity is equal to the mass of the object times g, 9.8. O, I'm going to say, is the mass of the object. Okay. Now, let's recall what our buoyant force is. So, the buoyant force, which in this case is going to be 50 minus 36, the difference in those two, that buoyant force is the weight of the displaced water. What does that mean? Buoyant force is the weight. Now remember, weight is in newtons. It's mass times gravity. So if I know the mass of the water displaced times gravity, I know what my buoyant force is. So remember, I'm trying to find what the density is. So if I put both of these masses in terms of their densities, it'll help me find the answer. Okay, so let's look at the first equation right here. Force of gravity, which in this case is 50 newtons, is equal to the mass of the object times the gravitational constant. So the mass of the object, if I want to isolate for mass, I just multiply density times volume. So I can say the mass of the object is the density of the object times the volume of the object. That's my mass. And then I have to multiply this by g. We're going to label this equation 1. Now let's look at our second equation. We want to look at the buoyant force. Now remember, the buoyant force is going to be the difference between these two numbers. Right? Here's 50 newtons. Here's 36 newtons. Something is pushing this object up, or else this would be the same number as this. What's pushing it up is the buoyant force of the water. So the difference 50 minus 36 again, just like we did for our object, for our water displaced, we want to write this in terms of density. So if I want to know what the mass of the water displaced is, I got to write this in terms of its density and volume. So this would be the density of water times the volume of the water displaced. And last is our G, our constant. Okay. Now, Archimedes' principle, when Archimedes was in the bathtub, and he noticed that the water was flowing over the side of the tub, he said, okay, any object that I put inside this tub, if the tub is completely full, the volume of that object will be exactly equal to the volume of the water that's displaced. So here's the volume of the water that's displaced, the water that would fill off the side of that, or spill off the side of that bathtub. So the volume of that water displaced, well, that's just going to be the volume of the object. So 15 minus 36, this is going to be 14, is equal to the density of water times the volume of the object that displaced the water. I'll say that again. 15 minus 36 is 14. This is the density of water. The displaced water is just going to be the volume of the object. Okay. So I'm going to cross this off. We're going to label this equation 2. My next step is we're going to divide equation 1 by equation 2. This gives, on the left side of the equation, it's going to be 50 divided by 14. Divided by 14. On my right side of the equation, I'm going to have this divided by this. Okay. So, let's see what we can cancel here. We can cancel V naught. Cancel G. So we're left with this relationship. Force of gravity divided by point force, density of water, or density of the object, density of water. 50 over 14. The density of water is 1 kilogram per liter. So my density of the object, multiply both sides by 1 kilogram per liter, I get 50 over 14 times 1 kilogram per liter. This is your final answer. The density of the object is equal to 3.57 kilograms per liter.